I would like to focus on 4 of the most basic measurements that people use when they're looking at statistical data. These are called the mean, the median, the mode, and the range. Let me try to explain these words first as vocabulary terms, if you will, and then we'll look at several examples of how these are used. First, let's talk about the mean, or what sometimes people call the arithmetic mean. It's simply the average of all the numbers in a set of numerical data. This is found by adding all the numbers in our list and then dividing that sum by the number of numbers in the list. It's arguably the most common statistical value that people use when they're doing statistics. A batting average for a hitter in baseball is a mean, and the average temperature for a location over the course of a month or a year is also a mean. Now, the second term that we'll focus on in this lesson is called the median. Now, the word median might make you think of some non-mathematical things. For example, when I hear median, I sometimes think of that concrete object that's in the middle of a road which separates the 2 directions of traffic. In fact, the word median comes from a Latin phrase which means in the middle. So how does the word median come up in statistics? Well, the median of a list of numbers is exactly that number which is right in the middle of the list after the numbers have been written from smallest to largest. Now that's the definition if the list of numbers has an odd number of values in it. How do we find the middle number in a list that has an even number of items in it? Well, it's simple. We simply find the 2 numbers that are in the middle and we take their mean or their average. We'll look at some examples in just a few moments of how you would calculate the median based on whether the original data set has an odd number of values or an even number of values. Now, the third word that we will focus on in this lesson is the mode of a list of numbers. Now, the mode is actually pretty simple to define. It's just the number which occurs most often in the list. So the mode is just that number that we see the most often when we're looking at our data. And finally, the fourth word that we'll look at is the range of a list of numbers. And the range of the list is simply the difference found by subtracting the smallest value in the list from the largest value in the list. The range helps us see how far apart the numbers are in our data, how much they vary from the beginning to the end of the list. And that can be really helpful to know. Well, it can be in some cases. In other cases, it might not be very helpful. But we'll see in a few moments in some of our examples that the range can actually help us tremendously. Now, certainly there are lots of other statistical terms we could look at, but we're going to focus our attention on these 4. And with those 4 now discussed as vocabulary terms, let's now look at a number of examples which involve statistics. And as we do those examples, I want you to notice how helpful it is to have these arithmetic skills understood that we've been building throughout this course. Now, let's first look at a couple of examples just to make sure we have the mechanics down. So let's take some small data sets and calculate these 4 values that we've already been talking about. First, let's find the mean, the median, the mode, and the range for the data set 12, 12, 14, 17, 20. So notice here that our data set has exactly 5 values in it, and we've already written them in order from smallest to largest. That's actually going to be very important as we do some of the calculations we'll do in a moment. Now, let's start with the mean. Remember, the mean is just the average of the numbers that we are given. So we first need to add up or find the sum of the numbers in our list. And that means we're going to find 12 plus 12 plus 14 plus 17 plus 20. Thanks to the order of operations stuff we've seen in the past, we know that we can just add these left to right if we'd like. We could regroup them some, although in this case, I don't really see any smart regrouping. So I'm just going to add them from left to right. And when I do so, I get the following. The 12 plus 12 is 24, so I have 24 plus 14 plus 17 plus 20, and 24 plus 14 is 38, so that gives me 38 plus 17 plus 20. 38 plus 17 is 55. I have 55 plus 20, and of course that is just 75. Now to find the mean, or the average, of my 5 numbers, I take that total of 75 and I divide it by the number of values in the original data set. There are 5 numbers in my original set, and so the mean is exactly 75 divided by 5. I can use some long division, although in this case it's not really all that necessary, but if I do so, I'm going to find that 75 divided by 5 is equal to 15. And so the mean of our list of numbers is 15. Now, let me make a couple quick comments about this mean that we just found before we move forward. First, notice that the mean of 15 is not one of the numbers in our list. This is very important to see. The mean does not have to be one of the numbers in the original data set. That, by the way, is not true of the mode or the median, usually. So the mean is allowed to be anything at once, although it's important that it lands in a certain range, which we can talk about later if we want. The second comment I'll make here is that the mean was a nice whole number here. It was 15. Well, that's actually not often the case. I rigged the numbers here so that the arithmetic would turn out nice in this first example. But keep in mind, the mean does not have to be a nice, clean, whole number as you're working through these kinds of examples. Okay, the next thing we should find is the median. Now, remember, the median is basically the middle number in the list. Again, the median I like to think of as that concrete divider, if you will, between lanes of traffic. The median for us is going to be that middle number. To find the median of such a list, I would sort the list so that the numbers are written from smallest to largest. And in this example, that was already done for us, so that's fine. And that now makes finding the median relatively easy to spot. In this case, it's going to be that third number in the list. It's the middle number in the list. And out of those 5, it's the third number there. In that case, it's 14. And so the median in this example is 14. Now, let's find the mode. The mode is going to be the number that appears most often in the list. Now again, this is easy to spot once you've written the list in sorted form, either from the smallest to the largest or from the largest to the smallest. In our case, the mode is 12, because in this example, 12 appears twice and every other number in the list appears only once. And lastly, the range. We need to find that. Well, the range is calculated as the largest number in the list minus the smallest number in the list. And so in this case, the range is going to be 8 because the 20 minus the 12, that would be the largest minus the smallest number in the list, is equal to 8. Now, let's look at another somewhat mechanical example, but it actually does have a couple different twists in it. I just want to make sure you see all these differences that can take place as you're doing some of these statistics. Let's find the mean, median, mode, and range for the following data set: 128, 124, 119, 126, 124, 113, 111, and 117. Now, let's start with the mean. Again, the mean is simply the average of the values in the list. That means I need to add the values together that are in the original data set and then divide by the number of values in the list. So first things first, I need to add those numbers. And when I do so, I'm going to have a somewhat larger looking problem, but it's just a bunch of additions. It would be 128 plus 124 plus 119 plus 126 plus 124 plus 113 plus 111 plus 117. Now you can go through those one pair of numbers at a time, if you will. For example, 128 plus 124 is 252. So the problem becomes 252 plus 119 plus 126 plus 124 plus 113 plus 111 plus 117. It's a lot of air to use to say all those things. And you can just keep marching left to right as you go through the calculations. And at the very end of all those calculations, you're going to find that the total sum of all the values in the list is 962. Now, getting to that 962 is something you need to do very, very carefully. And I hope you see that if you needed, you could find these numbers, these additions, if you will, by writing those numbers vertically and adding, not forgetting my carrying, of course, like we've done several lessons ago. So it's very important that you see that knowing how to add multiple digit numbers is extremely useful. And that's why we were doing those kinds of problems several lessons ago. Now, we're not done with the mean. The mean is not equal to 962. That's just part of finding the mean. Do you remember how you finished this problem of finding the mean? That's right. You take the 962 and you divide it by the number of values in the original list. And in this case, there were 8 numbers in that list. So now I need to find 962 divided by 8. And to do so, I would suggest we do some long division. Now, I'm going to warn you right now that, as with lots of means, as I've already mentioned, the answer is not going to be a whole number. So if you remember when we were doing long divisions with decimal numbers, we might have to put a decimal point right after the 2 in 962 and tack on a few zeros afterwards just to see what 962 divided by 8 really is. Now, let me suggest that you set up a long division problem. Draw the parenthesis and draw the horizontal line. Put the 8 outside as the divisor. Put inside as the dividend 962, and I might make it 962.00. And then remember, you have to put that decimal point up in the answer section before you ever get started. Do you see how these former lessons are really helpful as we build this mathematics one on top of the other? Now let's do the division. 8 goes into 9 one time, and so we put a 1 above the 9 in the answer section, and we subtract an 8 from the 9 in the work section. That gives me a 1 when I do 9 minus 8, and then I drop down the next digit, which is a 6. 8 goes into 1 6, which is 16, exactly 2 times, and so I'm going to put a 2 up in the answer section above the 6, and I'm going to put a 16 down below in the work section, and I'm going to subtract, and that gives me a 0 in my work section. Very good. Now, do we stop because we see a 0 in that work section? Absolutely not, because there's still a 2 up in 962, which has not been dropped down yet. So we have to keep going. We drop down that 2, and we now ask ourselves, how many times does 8 go into 2? Well, 2 is too small for 8 to go into it. So we have to put a 0 up in our answer section, just to the left of the decimal point, and then we need to drop down one of those zeros that we tacked on to the 962 when we wrote 962.00. Now I have a 20 down in my work section, and I ask myself, how many times does 8 go into 20? Well, 8 goes into 20 exactly 2 times, because 8 times 2 is 16. And so I put a 2 up in my answer section, just to the right of the decimal point now, and then I subtract 16 from 20 to get 4. Where did the 16 come from? It came from 8 times 2. Now I have a 4 down in my work section. I drop down another 0, which now gives me 40 down in my work section. And I ask myself, how many times does 8 go into that 40? Well, thankfully, the 8 goes into 40 an even number of times, or it has no remainder, I should say. 8 goes into 40 exactly 5 times, and it has no remainder because 8 times 5 equals 40. And so I put a 5 up in the answer section, I put a 40 down in the work section, I subtract, I get 40 minus 40 is 0, and since the only thing left to drop down would be zeros if I had added a few more zeros to 962.00, I'm done. I can actually stop at this point, and I see that my final answer for the mean is 120.25. Now, let's go ahead and move forward to the median now and see what the median is. Well, to do that, as I suggested in the earlier example, I'm going to ask that we rewrite the list of data from smallest value to largest value. This is going to help us tremendously with the median and the mode, and actually, to be honest, even with the range. It's really helpful to have the information sorted. Once you do that, the list of original data looks like 111 as a starter, then 113, 117, 119, 124, another 124, 126, and 128. Now we can find the median relatively quickly. Well, but it's not as quickly as in the other example, because in this example there are 8 numbers in our list of data. That means to find the median, there's a little more work we have to do in order to finish finding that median. We have to find the 2 elements of the list that are in the middle of the list. In this case, that's the 119 and the 124. They're basically the 4th and 5th elements of our list. And now to find the median, I actually have to take the average of 119 and 124. Now to find the average of those 2 numbers is pretty straightforward. I add the 119 and the 124 together. That gives me 243. I then divide by 2, because I'm taking the average of 2 numbers, and 243 divided by 2 is 121.5. So the median is 121.5, which is, by the way, relatively close to the mean, which we found a few moments ago, 120.25. Now, third, what's the mode of this list of data? Well, that's just the number that appears most often in the list. And now that we have the list written in order, it's pretty easy to see that the mode in this list of data is 124. And lastly, what is the range of the data set? Well, it's just the largest value minus the smallest value. In that case, or in this example, it's 128 minus 111, and that's equal to 17. Now, with those examples done, I'd like to look at a few examples that make us think just a bit. So let's start gently with the following example. The mean of Sam's first 4 exams in his course is exactly 90. If he earns a 95 on the last exam, what will his exam mean, or average, actually be? Now, some of you might be saying, as you heard me say the question, well, I can't find the answer here because you did not tell me the exact values of Sam's first 4 exam grades. You only told me the mean of the first 4 exam grades. Now, I can see why you might actually say that, but believe it or not, in this case, when you're finding the mean of these 5 exams, it turns out that being given the mean of the first 4 exams and the value of the 5th exam is actually enough to do the problem. And here is the key to being able to do this. For this problem, you can basically assume that Sam's first 4 exam grades were 90, 90, 90, and 90. Now, I'm not saying those are exactly what he got, but I can assume they are what he earned if all you want me to find is the mean of these 5 exam grades. Those numbers would have given him a mean of 90 on the first 4 exams, right? If he had a 90 and a 90 and a 90 and a 90, then the mean of those would be 90. And so I can make that assumption if all you want me to calculate is the mean. So let's use those 4 numbers, 90, 90, 90, and 90, along with this 95 that hopefully he's going to get on that 5th exam to see what his new exam mean would be. So how do we do that? We need to just take 90 plus 90 plus 90 plus 90 plus the 95. And when you do that, you're going to see that the first 90 plus 90 gives you 180. So then you can rewrite the problem as 180 plus 90 plus 90 plus 95, which is 270 plus 90 plus 95, which is 360 plus 95, which is 455. And now, to find this mean, we have to divide that 455 by some number. Well, how many exams will Sam have taken by now? He will have completed 5 exams. And so I'm going to take that 455 and divide it by 5. And if you do that with some long division if you need it, you're going to find out that 455 divided by 5 is going to give us 91. So Sam's exam mean is actually going to go up from 90, which is what it was after the first 4 exams, to 91 when he gets this better grade of 95 on the 5th exam. Now, before we go any further, let's make a few qualitative comments about this example we just did with Sam and his exam grades. First, did you notice that the mean went up when we brought in this 5th exam grade of 95? I hope you expected that to happen. You see, the 95 was a higher grade than the mean of his previous exams. And that implies then that his overall mean for his exams will have to go up once we throw that extra grade into the mix. So this is a nice way of thinking about means and extra data. If you know what your mean already is and you introduce more data which is larger, then you know that the overall mean will have to go up, and vice versa. If you have a mean and then you throw in some smaller data, then the mean will have to go down in the process. Secondly, notice that the mean only went up by 1 point. It went up from 90 to 91 when we factored in this last exam. And that's true even though the 95 is 5 full points higher than the average of his other exam grades. Why is that true? Well, because the weight, if you will, of that one exam isn't enough to affect the other 4 exams very much. If that 95 had been a lot higher, like a grade of 120 or 150, then it would have had enough weight or strength to raise the overall mean by a lot more. But as it is, it could only budge that mean just a little bit. And that's because one exam versus 4 exams just doesn't weigh all that much compared to the weight of those first 4 exams. And lastly, I want you to notice that we could not calculate the median, the mode, or the range in that problem the way it was originally stated unless Sam had told us exactly what the values of his first 4 exams were. Only the mean can be calculated here if we're only given the mean of his first 4 exams. And this is extremely important to understand. The median and mode and the range cannot be done there if all you're told is the original mean of Sam's first 4 exam grades. Okay, let's move to another example now that's of the following form. Arthur has exam grades of 82, 73, 45, and 92. Betty has exam grades of 75, 74, 73, and 70. Which statistic will tell us which student is more consistent with their exam grades? So I want to know which of the 4 numbers that we can calculate will actually show us a consistency idea, if you will, in the case of Arthur and Betty. Well, let's first find the mean of both students' exam grades. First, in Arthur's case, we would take 82 plus 73 plus 45 plus 92. And if we add the 82 and the 73, we'll have 155, and then we still need to add in 45 and 92. 155 plus 45 is 200. Now we have to add 200 to 92. That gives us 292. And what are we going to divide that by in order to find the mean? Well, we have to divide by the number of exam grades for Arthur, and that's 4. So we take 292 and we divide it by 4. And when we do so, actually, I've worked out the numbers nicely so that the mean turns out to be a whole number of 73. So Arthur's average or mean for his exams is 73. Now let's look at Betty's numbers. Well, she had 75, 74, 73, and 70. And when I add those 4 numbers up, I also get 292. You can check my arithmetic there, but that's what I get. And if I divide that 292 by 4 again, because Betty also had 4 exam grades, I'm going to get 73 again. So Betty's mean is also 73. Both students actually have the same mean for their exam grades. Obviously then, the mean isn't going to tell us or notice any difference between the 2 students because the mean is actually the same for both students. So that statistic isn't helping us very much as we try to tell the difference between the 2. Now, next, let's look at the median. Well, Arthur's median is going to be the amount 82 plus 73 divided by 2. Remember, when you're finding the median and the number of things in your list is even, then you have to take the average of the middle 2 values. So here, the number of things in our list was 4. That's even. So to find the median for Arthur, we're going to have to take 82 plus 73, and then we have to divide that by 2. And if you do that, 82 plus 73 is 155. When you divide that by 2, you're going to get 77.5. Now, what about Betty's median? Well, in Betty's case, you're going to be taking 74 plus 73 and dividing that by 2. And when you do 74 plus 73, you get 147. 147 divided by 2 is 73.5. Now, these two numbers are relatively close to one another, so I don't think they're really helping us much if we're thinking about trying to understand consistency between these two students. So let's move forward and see if either the mode or the range is going to do something for us. Let's look at the mode. Well, actually, none of the exam grades are repeated here. And so the mode for us is useless in this example because it's impossible to tell what's going on between the two students. The mode just isn't helping us. So lastly, let's look at the range. Well, Arthur's exam grades are going to range between 45 and 92. It's actually a pretty big range. And if I take 92 minus 45, I get 47. Okay. Notice that Betty's range, though, is only 75 minus 70, which is 5. So Betty's exam grades don't really change much. They don't really vary much. The difference between her highest and lowest exam grade is just 5 points. But Arthur's grades vary quite wildly by 47 points based on his first 4 exam grades. And therefore, in this particular example, thanks to the range statistic, we can conclude that Betty's exam grades are much more consistent than Arthur's. Okay, let's move to another example now involving these statistics just to see how the statistics can help us understand the situation. Here's the example. Alan is coaching a youth baseball team this year, and he just received his roster of players. Now, the league consists of teams of children ages 6 through 10 years old. He sees that he has the following age breakdown for his players. He has 2 6-year-olds, 5 7-year-olds, 3 8-year-olds, 2 9-year-olds, and 1 10-year-old. Now, I'd like us to find the mean, median, mode, and range for the ages of Alan's players, and let's interpret the data as much as we can. Well, let's start by finding the mean. Now, you might be fooled into thinking that our data set is actually the list 2, 5, 3, 2, 1. But that's actually not correct, although it's extremely tempting. Actually, our data set contains 13 numbers, since there are 13 kids on Alan's team. And the data set is really 6, 6, 7, 7, 7, 7, 7, 8, 8, 8, 9, 9, 10. Those are the ages of Alan's players based on the list we were originally given. Remember, there were 2 6-year-olds, so I'm going to have a 6 and a 6 in my list. And there were 5 7-year-olds, so I need to have a 7, a 7, a 7, a 7, and another 7 in my list, and so on. And that means now that my list actually has these 13 numbers in it, and from there I can start doing the statistical calculations. Let's start with the mean. To find the mean, I have to add all 13 of those numbers together and then divide by 13 because there are 13 numbers in the list. And if you add 6 and 6 and all those 7s and the 8 and the 8 and the 8 and the 9 and the 9 and the 10, you'll see that that sum is equal to 99. It'll take a bit of work. It's not really hard work, but it might take a few moments to get that sum to be 99. And now to find the mean, you're going to divide the 13 into the 99. Now when you do so, and if you use long arithmetic, for example, you're going to find that the mean is something like 7.62, and it's going to keep going. But I would suggest that after we find it's approximately 7.62, we sort of stop. There's no reason to keep working from there. So the mean is about 7.62. Notice that we knew the mean had to be somewhere between 6 and 10, since all the numbers in our list had to be something. Well, they were, but 6 and 10. The league, remember, has 6 through 10-year-old children. So if, for example, you had found a mean of 25.7, we would have known that was wrong. The mean had to be something between 6 and 10. Next, what's the median in this problem? Well, if you've written the numbers the way I did in order, 6 and 6 followed by the 7s, then the 8s, the 9s, and the 10s, we would see that the median is the number right in the middle of the list. And in this case, the median is the 7. It's one of those 7s right in the middle. So the median age of Alan's team is 7 years old. Thirdly, what's the mode? Well, the mode is also 7 in this case because there are more 7s in the list than there are any other number in the list. So not only is the median 7 because that's the middle number in the list, but the mode in Alan's team is also 7 because the 7 appears most often in the list of ages. Now, of course, we could easily see the mode from the original way the data had been written for us. We saw that there were more 7-year-olds than anyone else. And lastly, what's the range? Well, it's 10 minus 6. Largest number in the list is 10. Smallest number is 6. 10 minus 6 is 4. Now let's quickly interpret. Well, first of all, I hope you see that the mean, median, and mode seem to indicate that Alan has a relatively young team. Kids mostly around the ages of 7 or 8, and so on. Also, Alan has the largest range possible. He has 6-year-olds and he has a 10-year-old. So his team's skills have the potential to vary pretty significantly in the process. All in all, as with most statistics, there's not a ton that we can say about Alan's team. But thankfully, we can at least see something about the average age of his team. Next time, we'll move on to a cousin of statistics, which is known as probability. I look forward to that then.